This is CPM Precalculus Chapter 2, Number 9. If f of x is equal to 3x squared plus 5x minus 2, show that f of x plus h is equal to 3x squared plus x times 6h plus 5 plus 3h squared plus 5h minus 2. Okay, so what we're trying to do here is basically show that if we change the argument into f of x to be x plus h, we get something completely different, which should be, but exactly this. So let's go ahead and plug in, instead of x into f, we want to plug in the argument x plus h. That means everywhere we see an x here, we want to change it to x plus h. So here we have 3 times, now instead of x, x plus h, still squared, right? Plus 5, and instead of x, we write x plus h, and then minus 2. So now let's just simplify this, right? This is going to be 3 times x plus h squared, so that means x plus h again, plus, well, let's go ahead and simplify this. This term here, we can distribute the 5 and get 5x plus 5h, and then we still have the minus 2. Alright, so our next step, we want to keep simplifying this and see if we can get this over here. So let's distribute these two binomials and multiply them together, so we get 3 times something. So let's find out what that something is. I'm going to use the box method here. Okay, so I have x plus h times x plus h. X times x is x squared. X times h is hx or xh. X times h again is going to be hx again. H times h is h squared. Okay, so in my box here I have x squared plus, I have 2 of these, so 2hx plus h squared. Okay, and I still on the right have 5x plus 5h minus 2. And these are all different terms, so I cannot combine them. Okay, so let's distribute the 3 next. And we get 3x squared plus 3 times 2 is 6hx plus 3 times 1 is 3h squared. And then again, we have what's on the right, 5x plus 5h minus 2. Okay, this is pretty much where we would finish, right? Because there are no like terms to combine. But this does not look like what we have here. So what does that I mean, this 3x squared is here, okay? But we don't have an x times 6h plus 5, right? But we do have a 6hx, and we do have a 5x. So maybe if we rearrange this, it might look like that. And on the right, we have here 3h squared plus 5h minus 2. And we have 3h squared, 5h minus 2. So let's rearrange this, just reorder things to make them look more like what we have that we want to show it equal to. 3x squared is in the front, 6hx next. Now I'm going to put these next to each other, so plus 5x plus, and then on the right I'm going to put these 3h squared plus 5h minus 2. So now I have 3h squared plus 5h minus 2. I can put that in parentheses without changing anything. And now I just need to see if I can change this to look like this. Well, if you look closely, both of these terms have an x, right? So I can take the x out, factor out an x, and if I divide x into this term, I'm left with just 6h. And if I divide x into 5x, I just have 5. So if we factor out an x, it's going to look just like this. So let's copy down this term and this term with our parentheses. And now these match exactly, and we have shown that if our input is x plus h, we get this as our output. So this ends CPM Precalculus Chapter 2, Number 9.